So it says, let f be a positive, continuous, and decreasing function. So those are the conditions to be able to use the integral test. If this integral goes to 5, so that means it converges. You've got an answer. Then what has to be true about the series? Well, if the integral converges, then the series is going to converge to, and I think there were 2 that said that. Yeah, so it's either A or D. And the actual sum of the series is going to be slightly bigger than whatever result you got there. So that one's going to be D. All right, and then number 2, same thing, let f be a positive, continuous, decreasing function. If this series converges to k, so they didn't say what it is, but they said that it converges, then what else has to be true? Well, if this converges, it's almost the opposite of the question they just asked. If the series converges, then the integral is also going to have to converge. So that's D. So not necessarily to the same value. It won't necessarily also equal this K, but we just know that it's going to converge. So that one's also going to be D. So let's do quick, and then these ones we're going to have to, actually do some work for. All right, so this one, the integral test can be used to determine which of the following statements about the series. So we are going to set up an integral from 1 to infinity. And so it'll be limit as b goes to infinity, integral from 1 to b of this. And so I'm just going to replace the n's with x's. And then dx. So we're going to have to do a u substitution here because this is quite messy. We're going to let u equal 1 over x, which is x to the negative first. And so that derivative, you would bring the -1 down and it would drop to a -2. So it's going to be -1 over x squared dx. And so we have that x squared in the denominator and we have the dx, obviously. I just need to adjust for the negative. So I'm just going to move the negative to the other side. So this is going to be negative integral e to the u du. Oops. And so this will be limit as b goes to infinity, negative e to the u. This is its own antiderivative, which is nice. So negative e to the power 1 over x, evaluated from 1 to b. And then we're going to do upper boundary minus lower boundary. So that is going to be negative e to the 1 over b power minus negative. So that's going to cancel. E to the 1 over 1, that would be e to the first, which is just e. And then lastly, we're going to evaluate the limit. So if b goes to infinity, this numerator is going to go to 0. E to the 0 power is 1. So we get -1 plus e. And so the one that says that is A. We've got that -1 plus e here. And so the series converges since that came out to a numeric result. Again, e is about 2.718, so this is an actual value for an answer. Right, and then 4, the integral test can be used to conclude which of the following statements about this infinite series. So we're going to do the same thing that we just did for number 3 and do the integral test. So limit as b goes to infinity. Integral. Now this one starts at 2, so this would be from 2 to b 1 over x ln of x dx. And so once again, this is kind of a mess, so we're going to need a u substitution. We're going to let u equal ln of x, and so that derivative is 1 over x dx. So the 1 over x dx, we're substituting out, that part's taken care of. And so we're left with 1 over ln of x, which is u. So this is 1 over u du. And that antiderivative is ln. So we end up with ln of ln for this one, which is a little bit strange. That's what it came out to. So this is ln of x from 2 to b. And so we're going to do upper boundary minus lower boundary. So that'll be ln of b minus ln of ln of 2. And as b goes to infinity, this is going to head upwards forever. And so ln of a really gigantic number, you know, the ln function goes like this. So it's going to keep heading upwards forever. So this first part goes to infinity. So it doesn't really matter what this is. This is going to go to infinity. And so since the integral diverges, then we know that the series diverges as well. Oh, but they put more to this. Okay, so we can get rid of A and C. So you say the series diverges and the terms of the series have a limit of 0, or the terms of the series do not have a limit of 0. Okay, so we're going to do limit as n goes to infinity of 1 over n ln of n. And so as n goes to infinity, this denominator is going to get infinitely large. You'd have 1 over a gazillion, which is going to go to 0. So the terms of the series do have a limit of 0. So that one is B. I think they did that simply because if they only had series converges or series diverges, that's only 2 choices. So, you know, what would they make the other choices even be? They had to put something else in that problem there. And then this last one, I made this like extra credit. If you missed this one, I didn't count that against you, because this was just so strange. Consider the infinite series sum from 1 to infinity, 1 over n squared. The integral test can be used to verify convergence because it is positive, continuous, and decreasing. Which equation is true? All right, so they give 3 things here. I'm just going to look at the first one. They give us 1 plus integral 1 to infinity 1 over x squared dx. That's the first thing they give us. And then the second thing, I'm going to leave a bunch of room so I can work that out. They give us n equals 1 to infinity of 1 over x squared. So that's like the actual sum of the series. And then the third thing is integral from 2 to infinity 1 over x squared dx. What I would honestly do is I would just work these out, because these aren't going to be difficult integrals to do. It's not going to need a U substitution or anything. And I would just see what order these go in biggest to smallest. So I'm going to leave off this +1 for a second, just do the integral, and then I'll add 1 to it at the end. So the integral part of it would be limit as b goes to infinity, integral 1 to b, and I'll write that as x to the -2nd. And so when we do the antiderivative, we're going to raise the power by 1. So it'll be x to the -1, and then put a negative out front. So that's going to be -1 over x from 1 to b. And so we're going to do upper boundary minus lower boundary. So this would be -1 over b minus -1, so +1. And as b goes to infinity, this gets infinitely large. So this first part goes to 0, and then +1 would be 1. And then plus this other one from the very beginning. And so this whole thing is going to go to 2. And so then looking at the actual series, if you list out like the first few terms, like plug in like 1, 2, 3, and 4. If you plug in 1, you're going to have 1. So this is going to be bigger than 1, because we start with 1 and then we're going to add on to that. So if you plug in 2, you're going to get 1/4. And if you plug in 3, you're going to get 1/9. And then, you know, so on and so forth. What happens is you're adding on a smaller and smaller amount each time until you're practically adding on nothing. It's really like not changing hardly at all when you get out to really, really big n values. So 1 1/4, so like 1.25, and then like, oh, it might go a little bit higher than that. This isn't really going to go much more than like 1.4. You're going to be somewhere in that range, because you start adding on less and less and less. This is going to be like somewhere between 1 and 2. And then for this one, we're going to do the same thing that we did up here. And in fact, it's going to be the exact same antiderivative. So I'm going to start with that step, because it's the exact same function. It's going to have an antiderivative of -1 over x. The only difference is this one started at 2 and it didn't have a +1 out front. So upper boundary minus lower boundary, that's going to give us -1 over b minus -1/2. So +1/2. And once again, as b goes to infinity, this first part's going to be 0 and then plus a half. So this one would be a half. So that one's a half, this one's 2, and this one's going to be somewhere in between 1 and 2. So smallest to biggest, it would be this integral from 2 to infinity, and then the sum of the series, and then the one that had the 1 added onto it. So you see